Hello and welcome to another Edexcel iGCSE Computer Science past paper question. This is a sample assessment materials and we're already up to question 7. Question 7. Algorithms can be designed using pseudocode or flowcharts. Then they need to be translated into code that a computing device can execute. Figure 2 shows the pseudocode for an algorithm. So you may recognize this question from a previous video that I did, but we'll go through it again. This is pseudocode for an algorithm. Set in_num to 0, set result to 1, set I to 0. Okay, then I've got an output there, send enter a number, to display. Receive in_num from integer keyboard, so it's going to be an integer that comes in. If in_num is less than 0, then send invalid input to display. Else, if in_num equals 0, then send answer is 1 to display. So, and then I've got an else there, and I've got this calculation that it does, and it prints off the answer to that. So I need to complete this table using that algorithm, and I've got an input of 0 to start with, so we'll go back and have a look at that. So let's look at the conditions here. If in_num is less than 0, so it isn't. So if in_num equals 0, send the answer is 1 to display. So in_num equals 0, that was the input. And so here we're going to write answer is 1. That's 1 mark, okay? Now I've got -12 as my next input, which I need to go through the algorithm and trace it through. So I'm looking at this one here. If in_num is less than 0, then send invalid input to display. So that's going to be invalid. So far, so good. And that's got me 2 marks. Now my third mark, I've got 5. This is a little more complicated. Okay, because it's not less than 0, it isn't 0, so now I'm into this loop here. So for I from 1 to in_num do. So for I from 1 to 5 do. Set result to result times I. Okay, if you remember back here, result is I, or I is 0. Okay, so result times I. So let's get into this loop and have a look at what we need to do. So from I from 1 to in_num. So this is going to do 5 times. Okay, set result to result times I. So result is set to 1 at the start. So I is now 1. So I starts at 1 to 5. So we start with I equals 1. I've created this little trace table here. Okay. So now what I need to do is result times I. So that is 1 times 1. And so results then is going to be equal to 1. Okay. Next line. Now I equals 2. Okay. Because I'm looping through 1 to 5, so now I is 2. So now result is 2. So just move that back. Okay. Result times I. So that is 1. Result is still 1, and that is 1 times 2. 1 times 2 is 2. So result is now 2. Now I is now 3. Okay. And its result times I. So that is now 2 times 3. And 2 times 3 is now 6. I is now 4. Okay, result times I. So that is now 6 times 4, which is now 24. So just move this down. I is now 5, and this is going to be the last iteration. Okay, result is now 24, and that is times by 5. And so our output now is 120, and that's where we stop. So the answer there for the extra mark, okay, is the answer is 120. So next question, what is the purpose of this algorithm? It's working out the factorial of in_num, okay? So all that is doing is working out the factorial of in_num. So that's the answer there. Just make sure that I've written that. Yeah, that is correct. And that's given me 1 mark. And that is question A. Question B. A bus company sets fares for different groups of passengers. The fares are a child fare for passengers 15 years old or younger. Senior fare for passengers 65 years old or older. Full fare for all other passengers. What that's saying is that if they're between the ages of 16 64, they're paying full fare. Construct a flowchart of an algorithm that will determine fare for 1 passenger when age is input, no validation of input is required, and that's 5 marks. Now, to help me answer this, I prepared a PowerPoint. It's not always easy to draw with the tools in using Adobe, so I've created this PowerPoint to go through it. So when I'm asked to create a flowchart, the first thing I need to do is my terminator. I need my terminator at the start, and that was my start, and that's a lozenge shape. So first thing I need to do, probably most flowcharts that I'm going to create, probably I'll say 99% of flowcharts I'm going to create, is I need to get an input. And in this case, I need the age of the person. So I ask them to enter their age. Now, next one, I'm checking. First condition, age, less than or equal to 15. Okay, that's my first check. And that needs to be a diamond. That is a decision. If yes, it's display child. If no, I'm asking, is that age greater than or equal to 65? If yes, display senior. If no, display full. Now, the next thing I need to do is add a terminator, stop. And what I need to do is, after I've displayed child and after I've displayed senior, I need to link back to the stop. So everything goes down to the stop. So don't just leave this hanging here, this display child. Don't just leave that hanging. I make sure that that goes down to the stop. So that's the flow chart. So just go back and just have a look at the flow chart and just look at the requirements and make sure we've done that. So what it says is child fare, passengers 15 years or younger. Yep, done that. Senior fare, passengers 65 and older. Done that. Full fare for other passengers. Create a flow chart for an algorithm. And that's given me 5 marks. And this is my fully completed flow chart for 5 marks there. Make sure in your exam you do it as neatly as possible. Use a ruler, write in pen, use a pencil for the diagrams. Make sure you have all the outputs there. Use the correct symbols. So if you notice there, display child, that is an input output symbol. And make sure you have all the arrows where necessary, unless it's a loop that goes down to the terminator at the end. Unless you're looping back to another point in the flowchart, it needs to go to the stop. C. Complete the table indicating with a tick to show the characteristics of language translators. You may select more than one translator per characteristic. So I've got different characteristics down the left-hand side in the translators. I've got compilers, interpreters, and assemblers. So assembler, assembly language, we're thinking low level. Okay, assembly language, machine code, low level. Compiler and interpreter, high level. So we're thinking high level languages like Python, Java, Visual Basic, etc., C#. So what's the difference between the two? Interpreter, that is Python. Interprets the code line by line. Think of when you're writing Python code. When you get an error, it tells you exactly what line the error is on. So it interprets the code, converts that into machine code line by line. Whereas the compiler creates an executable file, which is then run separately, separate to the code. You don't need to have the IDE, like idle, open to run the code. Creates an executable file which we run separately. Okay, so that is Java. So compiler is Java, I believe C# and interpreter is Python. So go through the table and complete it. Okay, an error in the source code is highlighted as soon as it is encountered during execution. Okay, that isn't compiler and that isn't assembler, that is interpreter. Okay, second line, translates low-level programming languages. Okay, low level. That has got to be assembler. So I'll put my tick there. Translates high-level programming languages. Well, that is compiler and interpreter. So we put ticks in both. Generates a single executable file. Okay, that is compiler because it's not an interpreter. We generate a single executable file, and that is what a compiler does. And the final one line of source code is translated to one line of machine code. Now that could only be assembler, okay, because it's a line-by-line translation, unlike the other two. So that completes that table there, and that's the difference between compiler, interpreter, and assembler. So that completes the question. I just want to say a big thank you for watching the video. Thank you for getting this far into the video to the end. Please, 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 if I've helped you, if you found this useful, please consider liking and subscribing. I really appreciate my subscribers, and doing videos all the time. Every week there's a new computer science video, and I've yet to get into the practical stuff as well, so we're going to do that as well. So please, please, please like and subscribe, and I'll say thank you very much for watching, and I'll see you in the next video. Bye bye.